Hi, everyone. My name is Nathaniel Frissell, and I'm currently a research professor at the New Jersey Institute of Technology. I'll be starting at the University of Scranton as a professor in the fall. So what is HamSCI? HamSCI is the Ham Radio Science Citizen Investigation. And this is a collective that allows university researchers to work with the ham radio community to advance scientific research problems, our understanding of scientific research, and also to benefit the ham radio community. So it's a collaborative thing. And this came about because I actually went into ionospheric research because of my interest in ham radio when I started at about 14 or 15 years old. So HamSCI has three main objectives. One is to advance scientific research and understanding through amateur radio activities. Two is to encourage the development of new technologies to support this research. And this is where a lot of our interaction with TAPR has really come into play. And three is to provide educational opportunities for the amateur radio community and the general public. So I talked about general scientific research, but I would say our main thrust is really looking at ionospheric variability, understanding how the ionosphere connects into space and connects into the lower atmosphere. So what I'm going to do is just show you a smorgasbord of different research projects that we've worked on in the past couple years or we are working on now. And some of these are going to be given as booth talks during Hamvention or in the forum, the HamSCI forum, tomorrow morning at 9:15 a.m. in Forum Room 4. The full schedule of all the HamSCI booth talks and forum is available on our website, hamsci.org. So the project, okay. So the project you're probably most familiar with is the Solar Eclipse QSO Party, which was back in August of 2017. And we organized a big contest-like event that people all over the United States participate in to flood the airways with signals. And then we used the reverse beacon network and PSK Reporter and WhisperNet to collect those observations. We were then able to go through and analyze that, and you could see here, these are the signals. The colored dots are the midpoints between the transmitters and receivers during the Solar Eclipse QSO Party. If we trim that down to just look at the signals that were right across the eclipse line, you get this red here, and these are all reverse beacon network signals. And then you can bin them with time and create these really nice histograms relative to eclipse maximum, and they're organized by frequency. So here's 20 meters, and you can see the eclipse response here. Here's 7 megahertz. You can see how the band goes out longer and then comes back in. And then on 3.5 and 1.8 megahertz, you can see how the D region absorption started to go away as the shadow of the sun came across, and now you're starting to see those signals there. So that's the largest experiment we've done so far. I had a student, one of the important things with HamSCI is that we have student involvement as well. And so I had one of my students, Josh Vega, he ran ray tracing between all of the transmitters and receivers you saw in those previous maps. And he was able to predict where those, what the response of the ionosphere should be to this ham radio eclipse QSO party. And by doing that, we were able to get a nice comparison between scientific ionospheric models and the ham radio just operation during this event. And we were able to get that published in Geophysical Research Letters. So that's one way we're advancing it. In addition to having student involvement, we try to engage interested members of the ham radio community to participate and do their own analysis as well. Steve Serwin will be talking at the HamSCI forum tomorrow morning, and he is doing very fine frequency measurements of WWV at dawn and at dusk. And what happens is, as the ionosphere builds up during the day, the path length of a WWV signal can become less, and that can appear as a Doppler shift in the received signal. But you're not going to observe that with just a normal radio receiver. You need to make sure you have a very stable oscillator, and you have to have a good analysis chain. And so he was able to show that here. He also looked at eclipse effects using WWV and 60 kilohertz WWVB, and he looked at amplitude variations during the eclipse. I've also been trying to use the reverse speaking network in WhisperNet to look at responses to not just the eclipse, but to other sorts of space weather events. So in a recent paper that I again worked on with my students and with some of the other members of the amateur radio community, we looked at the response of the reverse speaking network and WhisperNet to solar flares. And so you can see during this solar flare on September 6, 2017, you had many HF QSOs in progress in the 15-minute period before the eclipse, and then much fewer after. And if you plot that in a time series, again, you can see these very nice drop-offs, and we're able to see how fast the ionosphere will recover, how fast it shuts down. And this was during the period where there were emergency communications going on due to Hurricane Irma down in Puerto Rico in the Caribbean. And so this had a very big effect on that. We also, one of my colleagues and friends, Dr. Gareth Perry, he is also here at the HamSCI workshop. He will be talking this afternoon at 3 o'clock at the HamSCI booth about his field day experiments. He has had access to a radio receiver on the Canadian Cassiope satellite that could listen to the HF bands from about 400 kilometers altitude. And so during field day a couple years ago, he turned on the receiver, and we were able to identify specific radio stations from below, and we could see at what point the satellite went over a higher density region of the ionosphere and cut out those signals. And we were able to use the reverse speaking network to confirm that the radio stations below were still transmitting. He was able to get this result published in Radio Science, which is really nice. And so now he actually has data from last field day, and he'll be listening again this field day with this same instrument. So as you're just participating in field day this year, you may also be part of a science experiment. As part of the education outreach, Carl Letzelswab, K9LA, he'll be giving a couple booth talks this weekend. One on the propagation of the new 630 and 2200 meter bands. And he'll also be talking about what he calls the third source of short-term variability in the F2 region ionosphere. And that is really, if the first source is just the diurnal variation, photoionization from the sun. The second source is geomagnetic storms and magnetospheric activity. The third source of F2 region variability are disturbances from below. So here he shows how tsunamis and can affect the ionosphere by causing waves in the atmosphere that propagate up and then create traveling ionospheric disturbances that can be seen in total electron content maps measured by GPS or affects HF radio propagation. Dr. Phil Erickson, who's the keynote speaker at the TAPR AMSAT banquet tonight, he's working on a project where you're using the WWV time signals to measure ionospheric variability. And you may say, well, what's so novel about that? Yeah, I just showed that Steve looked at WWV and you could see ionospheric variability there. However, this approach is quite novel because instead of just looking at, say, the Doppler shift, they're actually looking at the individual time ticks, and they're measuring the time spacing between those ticks. And it turns out that the ionosphere will cause variation in how close or far apart those time ticks are. So they're working on developing techniques to make that usable now. And finally, one of the big HamSCI projects that involves TAPR is the Personal Space Weather Station. And the idea is, can you create a ground-based receiver that ham radio operators might want to build or buy that could tell you about space weather and propagation right from where they are, and also build it out send that data to a central location where you could build a big picture. And so this might be a multi-instrument device that might have, say, a ground magnetometer, it might have a software-defined radio, and they might all come together to a single computer. And it can measure variations in currents in the ionosphere. It can measure variations in propagation. The part that we're asking TAPR to focus on is the development of this software-defined radio. You can buy many software-defined radios on the market today commercially, and some of them are quite inexpensive, but there's nothing out there that really meets all the requirements we need for an inexpensive scientific software-defined radio, something that has good characteristics in terms of stable oscillators, in good characteristics in terms of phase noise, and can actually timestamp all the measurements. So by working with TAPR on the Tangerine SDR project, that's going to be the basis for the scientific SDR, we're hoping to engineer that software-defined radio that can fit into that personal space weather station. And so, as Scotty said, he's going to be talking about it in the SDR forum today at 3:50 p.m. in forum room 3, and also more from the HamSCI side of things tomorrow at the HamSCI forum at 9:15 in room 4. So that's it. Thank you very much.
All right. Thank you, Nathaniel. And especially thanks for coming in on such short notice
Sure.
to help out.